All right, welcome to our first live session in operating systems. Hello from Sweden. So I'm not in Trondheim this semester, but I nevertheless agreed to take over this course a second time. So I already taught it last year. So this year we have about twice the number of students because that course has been moved to year 2 officially. So we have this year's year 2 student and last year's year 2 students on the course. So I just checked Blackboard, so it's around 430 students. So it's a really big course, which is in itself fine, but it might result in some delays answering requests. I hope this will be fine, but yeah, we don't have that many people supporting you. But nevertheless, let's just jump in. So the idea today is to give you an overview of how we are going to run this course. And yeah, some details and a quick overview of what we're going to talk about in this semester. So operating systems is the topic, obviously, and all of you have used operating systems before. Well, there's no way around it in computer science. And what you're going to learn in this semester is how an operating system works and how you can interact with an operating system as a programmer. So doing systems programming, usually from user mode, writing programs that interact directly with the operating system. So, whoops. Which lecture mode are we going to use this semester? Since I'm not in Trondheim and we currently have Corona restrictions in place, and we probably won't find a lecture hall anyways with space for like 400 of you with 1 meter distance regulations, we are running this course in flipped classroom or inverted classroom mode. What does this mean? So this means that, well, we'll put the videos of the lectures, they're pre-recorded, we put them online, so you can watch them whenever you have time. So in a regular week without any holidays or anything, we'll have 2 lecture videos out. So the first 2 lecture videos were the introduction to C programming, which came out last week. And the lecture videos for this week came out, well, last evening, so I put them online. The videos are on YouTube, which means that we won't have much problems with like a load distribution or availability usually. Now, of course, YouTube is sometimes nasty by inserting ads, which I wouldn't like. I hope they don't do it because I didn't agree to monetization. If you are annoyed by the ads, there are ad blockers like uBlock Origin I can just recommend using because they also save you from getting malware on your computer. So the idea is really that you can watch lectures whenever you like. You can rewatch stuff. If my English might be hard to understand for you, YouTube provides automatic subtitles, which work pretty well. The Norwegian translation of the automatic subtitles doesn't really work that well, so the artificial intelligence is probably limited by the amount of well materials it can be trained with. So what we would usually do in present sections would be we would replace the lecture times with group work sessions where you could be present in a lecture hall. Well, that's not possible, so instead, we're going to do weekly sessions on Zoom. These might be Mondays, 12:15 to 1 o'clock or 2 o'clock, depending on how much things we are going to discuss. And what are we going to do? We're going to discuss the most important things from the previous week's lectures. So it's just a review or a retrospective overview of the important things that you should have noticed in the videos from the previous week. There's a time for general questions and answers on lecture contents, on logistics, on exercises. And we'll also have an additional session, which is Mondays at 2:15, which will be provided by our PhD TA. And this means that we'll have discussions of solutions to exercises that have to be handed in. We'll have a presentation of the new exercises that will be coming, and so on. So this will all be on Mondays usually, unless we'll have a well, important reason to shift it, and then we'll announce it quite a bit in advance, obviously. So course information. You are probably registered on Blackboard, and now, to be honest, I think Blackboard is not the ideal tool to use it, to say the least, for such a lecture. So I decided to well, present all information again in the most simple way possible, just putting up a stupid simple web page at that URL. So that's the web page where you can retrieve most of the information. So we'll put the syllabus on there, the lecture slides, the exercise sheets, links to videos, and so on. So as I said, lecture videos will be on YouTube, and we'll link them from the web page. Nevertheless, we'll have the course on Blackboard first for knowing who is registered for that course, and second, because the exercises will be part of the grade. Some of the exercises will be part of the grade. You have to submit them there, so we can grade them there, and we'll also send announcements on Blackboard. I would also like to provide a discussion forum. We're still looking for a working solution. So in previous years, Piazza was used. You've probably used it before. Now Piazza has changed to essentially commercial solution, which means that I'd love to find a solution that works without paying anyone money. If that doesn't work, obviously we'll still pay for it. We'll announce this hopefully later this week. Piazza would actually be nice because it would enable you to well, solve questions interactively between you, and not just well, in a hierarchical session, just asking us. So essentially, that's nice. So there's a proposal. The mathematics department has a nice firm solution. Oh, that sounds good. I'll check this out. Thanks. That sounds good. Can you pin the first announcement message on Blackboard so we don't have to scroll down to the first announcement to find the link? Yes, I can do this. Okay. So exercises. So we expect you to do a bit of work during the semester. So we'll have two kinds of exercises. We'll have theoretical exercises. These are recommended. Recommended means they're not mandatory, but still very helpful to prepare you for the exam. Now, we can't grade, and we don't want to grade too many exercises because we know you all have a stressful semester anyways, and Corona doesn't make it better. So we'll hand out, depending on the holiday situation, 5 or 6 theoretical exercise sheets. So the first one will be handed out later this week. And if you hand in a solution, you'll get feedback on that. So it will be feedback, you will get comments and corrections, but they will not be part of the grade. We will publish a solution, obviously, for the theoretical exercises. So even if you don't hand any solution in, you'll still can compare your solution on your own. In addition, we'll have practical exercises. So for me, for operating systems, it's important that you actually get some hands-on experience in programming and interacting with an operating system. So that's why we had our C Crash course. So the practical exercises are mandatory. Now, last year, we had 5 practical exercises, which led to students complaining it was a bit too much work. Agreed. Now, considering that it was too much work, we are reducing the number of practical exercises this year to 3, and accordingly, you get more time to work on that. And they will be a bit more complex. This is also helping us because we don't have the person power to grade 5 practical exercises for like 400 something students. So sometimes subsequent exercises can be based on earlier ones, but we try to make them as independent as possible. Yeah, and we'll also publish solutions so you can actually just also figure out what our idea for solving a practical exercise is. So the practical exercises will be corrected and graded, and you will get feedback and comments. And the practical exercises make up half of the overall grade. So each practical exercise is worth 1/3 of the half of the overall grade, or 1/6 of the final grade. To help you reduce your workload and to help us, well, obviously reduce our workload a bit, we would like you to submit solutions in groups of 2 or preferably 3 students. So our TA, Espen, has prepared a spreadsheet. So please use this SharePoint link. You can download the PDF from the website and fill in group partners there. Thank you. Exactly. And then please do this until the end of the week. And then we close the spreadsheet, and then you can enter these groups in Blackboard. Please do this on your own, because entering 400 of you in Blackboard is no fun at all, and importing usually doesn't work. So we hope this works in self-organized mode. If not, well, let us know if there's problems showing up or anything. Of course, we're able to help. So submission dates of the theoretical and practical exercises can overlap. But since theoretical exercises are not mandatory, you can obviously reduce your stress a bit. And we try to make the theoretical exercises in such a way that they also serve a bit as a preparation for the practical exercises. So, as I said, we have 3 exercises this semester, and our current plan is you have 3 weeks time to submit, and we'll start a bit later so you can collect a bit of knowledge to be able to work on your exercises. And what I didn't mention so far, which operating system are we actually looking at in detail? So we're going to explore the Unix operating system, which also works for Linux. And we're going to take a look at the interface between user mode programs and the operating systems. So these so-called system calls, which means all sorts of things for process management, synchronization, memory, input-output handling, and so on. I have to tell this, but of course you hear it in every course, plagiarism is not accepted. So if we find out that you copied a solution, well, we'll obviously need a stern talk to you, and in the worst case have consequences. Sorry to have to tell you that, but we had cases last year and it always happens. So please just try to be honest. And if you have problems, just rather contact us instead of just copying someone else's code. I would like you to understand things, even if it's a bit hard, maybe at times. If you've never programmed in C before, you've never programmed on that level, it helps a lot later in life. So our current idea is to publish 3 practical exercises with 3 weeks time each. So the first one will be published in week 5, so on the 31st of January, and you'll have 3 weeks time for submission, so until the 21st of February. And the first one will be about system calls and processes. Then in week 8, on the 21st, we'll publish the second one, which has a deadline of the 14th of March. This is about synchronization of processes. And in week 11, on the 14th of March, we'll publish the final one, and submission is before Easter. So last year we had an exercise over the Easter break, and that ruined many students' Easter breaks. So I want to avoid this year. You deserve some free time. You have exams to write, so that's fine for me. And this is about memory. And also, just in case we figure out some exercise was more complex for you than we imagined, so you take more time, this gives us enough space to maybe postpone a deadline in case many of you need more time. So we're able to adapt. We can do this. Just let us know if there are problems, if there are errors. Please, I love to have feedback. All right. So letter-based grading is obviously mandatory this semester. And as I said, we have 2 parts. So a practical exercise, or the practical exercises which make up 50% of the grade together, and the home exam, which makes the other 50%. There was a question, what if we don't have other group members? Do we just sign up somewhere random? Just want to make sure, do not modify the assignments of other students, doesn't disallow group searches. Well, if you don't have any other group members so far, just enter your name in this spreadsheet on a new group, and maybe other students who also don't have other group members can either contact you if you want other group members, or if you already have a group, but then you should just enter all the group members at once. And if there's just a single group member on a line, maybe just get in touch. So I hope that works. So the home exam obviously won't be a multiple choice exam for well, obvious reasons. So the exam will be obviously based on lecture contents and also the theoretical and practical exercises. We are going to publish an example exam with typical questions and solutions, obviously. And we'll also have a Q&A session before the exam, so in the last week of the semester for this. So this will be available with enough time before. Will previous exams be made available? Yes, well, there will be one previous exam made available because this course was completely redesigned last year. So I can make the last year's exam available. Exams from years before 2021 are not relevant. So just in case you have some transcripts of the exams, our exams will be different because I took over that course last year. Okay. So we have teaching assistants. So Espen has already written some stuff in the chat. So Espen Hogsdal, here's his webpage, is also able to support you and will help you with the exercises. And I'm still waiting for the official confirmation from the department about the student teaching assistants. So as it seems, we have 3, hopefully 4 student teaching assistants who will also help, so who will be available in the chat or in the forum. And well, in general, well, as soon as we can be on campus again in any significant capacity, maybe also offer Q&A times where you can just come with your problems and help and get some help. Let's see how this goes. Otherwise, we can still offer some Zoom sessions so you can get some more support. So what are we going to talk about this semester? So first, we're going to start with a bit of computer architecture. Now, many of you have already had an introductory computer architecture course, so we're going to take a quick review. But this is important because the operating system is the part of the software in your computer that interacts directly with hardware. So you need to know a bit about hardware, like the general structure, memory, I/O devices, interrupts, things like these. Then that's also part of this week's lecture, the challenges and tasks of an operating system. So why do we actually need an operating system? What is it actually doing? And what are the problems when you write an operating system that you encounter there? Then we look at what I call control flow abstractions. So when we want to execute code running on our operating system, so a user program like Word or MX or whatever, or Unix shell, how does this work? So how can we provide abstractions here? Processes and threads are the terms here. So we take a look at how they are represented and how they work internally, and of course, how you can use them. Now, if you have different things running in parallel, so modern computers always have things running in parallel, there's concurrency. And sometimes you want like several processes not to interfere with each other. So let's say you have 2 programs, each of the programs wants to print something on your printer. So of course you don't want one page printed by one program, then the next page printed by the other, then the third page printed by the first program. So you have to sort through your pages. So you'll have to control access to what we call resources in our computer. So in this case, the printer. So this is what we call mutual exclusion or synchronization. So there are mechanisms for doing this. We're getting to learn these, and the problems that can also happen here, like deadlocks. Memory is a very important part of your computer. So we have one big memory in a computer nowadays, and we have several processes running at the same time. So we have to split up that memory between these different processes. So in turn, we have to figure out how to manage this, how to virtualize this. Then we talk about scheduling. So when we have multiple processes, we also have to share processors. So on a single processor system, also on a multiprocessor system, we'll talk a bit about special case real-time systems for embedded systems where timing is critical, because otherwise your car might crash into a tree or something like that. So this is important. And finally, we'll talk about input-output. So how do we actually talk to our devices like disks or Ethernet or simple keyboards. How do we work with disks? How do we provide files on a disk? And then we'll go a bit into advanced topics, which, well, are hot topics nowadays. So virtual machines and microkernels. So all the cloud nowadays is based on virtual machines. So if you get a VM at Amazon AWS, so on the EC2 cloud, for example, you usually get a virtual machine. So we'll take a quick look at how this works. It's just an introduction, obviously, because you can spend a whole semester on this. We'll take a look at current infrastructure. So how do operating systems for the cloud work, and which special versions of systems can be found there, like unikernels and single address space operating systems. We'll talk a bit about the other end of computing, so small systems, embedded systems that are somewhere in a bigger device, so like pieces of hardware controlling the car. And we talk about so-called non-functional properties. We've already seen timing, but we can also talk about maybe energy and reliability. And finally, an important thing, we also have to talk about security in operating systems. So how can we avoid other people accessing information that we want to keep secret? So this is quite a lot for this semester. So this is split into separate lectures each week. And these lectures will be pretty similar to last year's lectures. We'll do a bit of restructuring to put a bit of more emphasis on multi-threading instead of just processes. So if you actually are interested in last year's lectures and already want to catch a glimpse of what we did last year, just use the URL from our page and replace it 22 by 21, and you'll get the links to last year's videos. There were some audio problems on a number of the recordings, so we'll go through them and fix the audio for this year. So there was some problem of disturbance and the audio level being quite low. So we're trying to fix this for this year, obviously. So there was another question in the chat. Why is it preferable to be 3 on the groups rather than 2? Well, because it reduces the number of solutions that are handed in for us, to be honest, because if we divide like 430 students by 2, we have 215 solutions to grade. And if it's divided by 3, I'll just be honest about this, this reduces our workload a bit. And of course, it reduces your workload a bit too, because maybe, you can split it. Now, of course, there's always the danger in a group of 3 that 2 do the work and the 3rd person doesn't. But that's life, I guess. All right, what else do we have? Not a lot, to be honest. So, of course, you might be interested in what literature you could use as background to get more information. And we have 2 books here. So you're not required to get any of these books. So the lecture materials are definitely sufficient for working on the exercises, for, of course, also writing the exam. But of course, if you want more information, there's a very good and free book from 2 colleagues in the US, Dempsey and Andrea Placido. Operating Systems, 3 Easy Pieces. Well, if they're easy, I don't know. But the good thing is the PDF download is free. And there's also a traditional textbook by Stallings, Operating Systems, Internals and Design Principles. And that should be the current edition, the 9th edition. That has become quite expensive. So this is one of the traditional OS textbooks. If you have any of the other textbooks on operating systems already, like Tannenbaum's Modern Operating Systems, for example, they're perfectly fine. And of course, we'll put additional information that might be interesting on the site, on this webpage, again, that I mentioned already. So I guess that's all from my side. One thing I should mention, we are working with Unix and Linux system interfaces. So does this mean if you don't have Linux installed, you can't participate on the course? No, you can. So what we're making sure, that has worked last year already pretty well. No matter which operating system you're running, out of the 3 operating systems, Linux, whatever version, or any other Unix version that's halfway recent, Mac OS X, or Windows, you will be able to solve the exercises. Now, Mac OS X is Unix, as you probably know if you have used the Mac, so that's not too problematic. how does it work with Windows? Now for Windows, there's this WSL subsystem. So this is a Windows subsystem for Linux. So this means you can install a Linux virtual machine right into your Windows 10 or I guess Windows 11 installation if you want. And then you have a complete Linux environment in which you can do development like if you were running it on a real Linux machine. So no need to install a separate VM or to do dual boot. If you want this, of course, it's nice. Or if you have a Raspberry Pi sitting around, that should also work with Linux. So we'll try to make exercises that should work on all platforms. So there's the question, which editor should we use to program in C? My Mac does not have enough memory for Xcode. Which other editor should I use? Well, you can essentially use any text editor that stores the text in really ASCII text files. So I've seen first-year students who try to edit program code in Word. That obviously doesn't work because then you get all the formatting and stuff. So you have to find an editor that is able to save text as just pure ASCII text. So I like to use, I'm not sure, I have to check. So I'm an old Unix guy, so I'm doing this for 30 years. So I'm using VI or Vim, but I don't want to force Vim on you. It's a great experience to learn, but it can be really frustrating. So on the Mac, I would suppose something like BBEdit or SubEthaEdit. I think both are free now, would be nice. So Xcode is definitely overkill for this. But in essence, on Windows with a WSL system, you could also use VS Code, I guess, if you like, but that might also have memory problems on the Mac if it got run Xcode. So you can choose the editor you really like. Yeah, VS Code is also a bit important. Yeah, next question was about, where are we here? Okay, there's a recommendation of WSL. Exactly, that's simple enough. And Vim, yeah, yes, I can recommend it, but it takes some time to learn. So how about people using M1 Macs? Well, I'm running this here on an M1 Mac. This is Unix, so you don't need a virtual machine to set up. So you can use all the system calls. You just have to install the Xcode command line utils on the Mac, which is a separate download from regular Xcode. I can put up a link for this if you need it. And this gives you a command line compiler, so a Clang compiler in this case is not GCC. And if you use on the Mac either Homebrew or Mac ports, there's also GCC ports available right now. But it will work. All exercises should work with GCC and with Clang, so that's not a problem. There's other recommendations for editors. Yeah, VS Code, that's fine from my side, but it's also a bit demanding on the hardware, I guess. On Windows, Notepad++ or Sublime Text. Yeah, that's good. Are lecture slides for future lectures complete? We will do some subtle changes. So the ones from last year give you quite a good overview of what we're going to do, but we'll do some changes and we'll maybe fix some errors we notice. I want to release them week after week to be able to actually be able to react to questions that have come up, to problems in understanding and so on. But if you want to have a look at last year's lectures already, these slides are online and we won't do that many changes. As I said, the biggest change will be we'll put more emphasis on threading. So there's a relatively short slide set on multi-threading, and we'll extend this to discuss p-threads more. The next question is this lecture flipped classroom or is it the lecture at 14 to 15? Yes, that's a good question. That's a matter of definition. It's part, both of it. So in this lecture, usually, so from next week on, we'll discuss the important contents of the lectures from last week, which is part of a flipped classroom session. And then we'll have a Q&A, question and answer session, where you can just ask things that you didn't understand or that you found a mistake or something like that, or just general discussions, of course, about operating systems are also welcome. And the lecture at 2 to 3 is discussing the exercises. So today there is no exercise so far, so there will not be a lecture at 2 to 3. So we'll have them in upcoming weeks. Was the pre-recorded videos from 2021 the same videos that will be released for the 2022 semester? Mostly. We'll make some changes, we'll make some updates wherever it's required, but essentially the addition will be p-threads, and we'll maybe take some things out. So last year we had a guest lecture by Anna Elster, which if I remember correctly, was not recorded. I'm not sure if we can have this year. So Anna does high performance computing, which obviously is very relevant to operating systems. So it would be interesting to have her point of view again. And last year we also had a session where actually I asked you, that was a second security session in operating systems, where I asked the students to watch a video from a colleague at MIT on security, just to give you an idea of what lectures look like at different universities. So maybe these won't be part of this year's curriculum or syllabus. We'll have to see how much time we'll actually have left over at the end of the semester. So but these were also not part of the exam, so not part of the required knowledge for the exam. So they were just additional information, which I'll have to provide for those of you who want to dig a bit deeper. So maybe, well, what would be interesting to me is a bit of a like show of hands. I'll open a poll. Who of you already has used Unix or Linux before? Let's see if this works. That doesn't work. Just a second. So just to get an idea of the distribution, so I would be happy if you could, yeah, fill this in. Okay, answers already coming in. Oh, this is quick. All right. Some more coming in still. Well, it looks like almost 3/4 of you have used some sort of Unix before. That's nice. So yeah, for those of you who haven't, don't worry. Like we'll explain Unix concepts, and what will probably help is also the link I already put on the webpage for the lecture, which is the missing semester of your computer science education, which is a great course by MIT, which we should also have at NTNU. I have discussed this a number of times already, but it's difficult to get it in. So this will explain things like how to use a Unix shell, how to use a makefile and stuff like that, which you might have already experienced when you've worked with Linux or maybe macOS on the terminal before. But that's great. So I hope I can also give those of you who have worked with Linux or macOS before a bit more of an insight of how this works. And yeah, I guess the important thing is also we have some fun working on that stuff. So we got very positive feedback from last year from our students, which I was very happy about. But of course, we can always improve. So if you have any feedback on how to improve things or what to add or what you would like to see, get in touch with us, and I'm happy to give you additional information. I'll just end this poll now. Let me take a screenshot first to show my colleagues, so nobody will be will be thinking that you're all just using Windows. Right. Okay. Show results. Yeah, I can show the results, obviously. All right. So let me check. What do you mean by other Linux? I hope I typed other Unix. Sorry, I just saw this now. So other Unix, so there are more Unix versions out there. So Unix is an old operating system. Actually, Unix has its 50th birthday, or had its 50th birthday last year. So it was created in the early 1970s. And originally it was a research project at Bell Labs, so the research unit from AT&T. And this was turned into a commercial product in the early 1980s. And so people could, or companies could license Unix and build their own versions of Unix. So was a version of Unix by a company called Sun Microsystems called Solaris. There is one by IBM called AIX. There's one by Hewlett Packard called HPUX. And there were many more strange operating systems that all were related to Unix. And there were also research versions of Unix. And the most important research version of Unix was developed in the late 80s, early 90s at the University of Berkeley in California. So there was the Operating Systems Research Group, and they built the BSD Unix version. So BSD stands for Berkeley Systems Distribution. There's a bad joke that says there are two good things coming out of Berkeley, BSD and LSD. I'm not going to comment on this. Nevertheless, so BSD was running on big computers like mainframes and large server systems in the 1980s. And then PCs became powerful enough at the start of the 90s to actually run Unix. So that was the class of a 386, 486 computer. So probably, much older than you are. Nevertheless, some people ported this BSD system to run on a regular PC. And then they got into legal trouble because AT&T thought, well, that's our code. BSD shouldn't be able to put this out freely. And at about the same time in the early 90s, there was this guy from Finland called Linus Torvalds, who got a bit bored in his computer science courses and who decided he wants to write his own operating system. If you see the announcement, I'll probably post some of the links to his early announcements from 30 years back. He said, oh yeah, just a hobby project. It will never be as big as Unix or something. Well, this is what is called Linux now, obviously. So Linux is not a Unix system in itself. So it's not based on the Unix code base, but it works pretty much the same as Unix and now has obviously taken over the place of traditional Unix. But these BSD Unix versions, for example, are still out there. So there's FreeBSD, NetBSD, OpenBSD, and another version called Dragonfly BSD, which is developed by a friend of mine. These are also available. So two of you have actually clicked, I have used another Unix. So it would be interesting for me if you two could just write which Unix you have used, if it was not Mac OS or Linux. Well, Arcus Linux, sorry. And somebody clicked wrong. Oh, it's okay, no worries. I mean, there could be people who use BSD. So there's a guy here in Sweden, in Luleå, who is one of the NetBSD maintainers who runs the old WAX mainframes from the 1980s. Somebody clicked, has tried FreeBSD. So yeah, that's nice. That's perfectly fine. So yeah, but anyways, I guess it doesn't really matter which sort of Unix you use. And maybe some of you who have used Windows until now exclusively will get some motivation to at least take a look at Unix or Linux just for fun. Okay, there's one other question. Will we ever just for fun look at Temple OS? Now, the poor guy who wrote Temple OS, unfortunately, I think passed away last year due to corona-related complications. I think it's an interesting system. This person was in the most positive sense of the word crazy, because writing an operating system all on your own is tough. You can do it. And I have written my first operating system in high school when I was 16 years old, but of course it was much less complex than the operating systems we have today. And there are some other problems out there. So there's another person in Sweden, Andreas Kling, who built his own operating system over the last couple of years, and this is called Serenity OS. I know Andreas a bit, so maybe I can convince him to give a guest lecture on Serenity OS if you're interested, to give you an insight of, yeah, how can a single person start getting an operating system to work? It's fascinating. Yeah, if you're interested in stuff like that, we can certainly add things. We cannot go too deep into kernel details because this is an introductory course. It's mandatory for all of you, I think. So essentially, yeah, I would stress you too much. And there's unfortunately no advanced operating systems course. But if you're interested in more details, I can certainly provide you with links. All right. So that's all from my side for today. So the videos are out there. Watch them whenever you have time. When there's problems understanding things, when there are things that are not clear or obvious, or you just want to get more details, let us know. Our next session will be next Monday, or next live session. And before that, you'll also get a theoretical exercise sheet. Now, next Monday, I'll be in Germany. But I was told that they actually have internet in Germany now, so yeah, that should work. Will all live sessions like the Q&A be recorded? Yes. Within how much time after the session will they be published? Well, usually, yeah, the day after, I would guess. So we'll just go through to check if there is no information that should be just left out. Will we not be using the time slot on Wednesday? No, we won't, because well, you can use it to watch the videos, but you can watch them whenever you like. We can use the time slot on Wednesday in case we actually absolutely need more discussion or more information, but usually we won't use it. Is that a standard? Okay, a standard for what? Yes, probably other lecturers will do it in different ways, but there's only so many hours in a week. So unless, yeah, if we really need to use that slot on Wednesdays, we'll announce it at least a week in advance, I guess. And the transcription actually works pretty well, so that's nice. All right, so I guess all announcements this week. So whenever the theoretical exercise is ready and any other things will be, so especially the forum stuff will be announced on Blackboard. So you'll get a message about this. And if there's anything, just let us know. For now, by email, preferably, just send me an email. Well, then as soon as we set up the forum, that's probably the better forum to interact, because then all the other fellow students can also benefit from that information. But of course, if you have a question that you don't want to ask publicly, but just in private, just always feel free to send me an email. All right. So that's definitely all from my side now. Time for lunch. Anything else from you? It's both a theoretical and practical assignments group based, I guess that should mean. It would help, because giving you feedback for 400 theoretical exercise submissions might be difficult. And in addition, I think you cannot split the submission functionality in Blackboard between two sorts of exercises. At least I couldn't figure out how to do this. So I guess you have to submit in the same groups for practical and theoretical exercises. All right, you're welcome. Okay, have a good day, and thanks for joining, and I hope we'll have a bit of fun and you'll learn a bit about operating system. So I'm doing that stuff for 35 years now. I still find it fascinating, though it's a bit shocking for me. It's already 35 years. And yeah, it will help you, because, you know, I had a student, I had a student last year who was trying to get an internship at CERN, so the European Nuclear Research Center in Geneva, in Switzerland. And a friend of mine from school is working at CERN for 25 years. And he told me like, we get like 1,000 applications for 100 places of internship. And 950 of them are big data, machine learning, artificial intelligence, and they're all immediately sorted out because we're just swamped with these applications. But if you have special knowledge in things like parallel computing, operating systems, compilers, and things like these, so system level topics, then you're really, really wanted, just because this is a bit of a rare breed of students nowadays. So maybe that helps if this interests you, well, to get a different view of computer science even. So I hope you like it, and if there's anything you don't like, let us know. I hope the C programming won't turn too many of you off. It's just another language to learn, and it's good to learn C because you'll also learn when not to use C, which is also important. Okay, so somebody wrote, we've had exercises in the past with multiple groups, new group per assignment. Ooh, we'll try to figure this out. How this works, that's, well, Blackboard. Maybe we can figure out how this works on Blackboard. We'll have to try. Did you say that this course included more focus on concurrency and multi-threading? Yeah, this course will include more focus on concurrency and multi-threading this year, exactly. Yeah, because it's important. You have like whatever 8 or 10 or 12 CPU cores in your system nowadays, so you should be able to use them efficiently. All right, so thanks for joining. See you again next week from Germany. And yeah, I hope we'll have some fun in this course. All right, so see you, bye.